Hi there. In this part of the PySpace theory, I want to discuss electromagnetism and how it is treated in PySpace. The um, the idea of PySpace is not to necessarily rework the existing formulas. The idea is that the formulas are fine. They're, it's just to provide an enhanced understanding of how they work theoretically. So one of the key ideas in PySpace is the idea of a Pi shell. It's an extension of the atom, and I've done a lot of work on that if you follow the videos. But one of the interesting aspects of electromagnetism um, is that it basically, when the electromagnetic wave basically flows at right angles to itself. You have the electric wave and the magnetic wave. So we pretty much accept that this is the case, and we just work from there. So in PySpace, there is an attempt to explain why is it that there are these right-handed rules and uh, perpendicular fields to one another. So the idea is pretty simple. It requires a certain degree of thought, but the idea is that the pi shell for electromagnetism is a pi shell like a massless, like a chargeless pi shell, except that it's in the fourth dimension. So in order to understand what I mean by that, you first have to understand what it means for something to be in the fourth dimension. So the idea is that if you take a tesseract, which is a kind of a visualization of the fourth dimension, you have an inner cube here, which is our traditional three dimensions, x, y, z. So if you imagine every point in our space-time having, for sake of argument, a tesseract, and we pretty much exist inside the three-dimensional one, but there's this external set of dimensions, this additional dimension around us, a fourth dimension. Now, how do I make that assumption? How do I assume that? Well, the idea is that if you look at the Lamore formula, uh, it's a q squared a squared divided by c cubed formula, and if you multiply the charge squared, you get a four dimensional result, which is the charge squared. It's area squared. Area is itself squared, so it's four dimensional. So the idea is that when you see a formula that has q, and this is pi space now, if you see a formula that is q squared, essentially you're talking about a tesseract. Now, how does the tesseract manifest itself in a three-dimensional reality? So the idea is pretty simple. Inside this diagram here, there's an inner cube, which is our three dimensions, and around it are these additional higher dimensions. But the idea is that we adopt a shared dimensions approach, and all that really means is that each of these boxes has its own three dimensions, and some of the dimensions are shared with the inner three dimensions, which are our dimensions. Um, and because of that, we see things at right angles. So I'll just move on a little bit. So the idea is that the charge is a four-dimensional pi shell, which is to say that it exists um, in the outer cubes. It exists out here. We know it exists because we know that charge has these electromagnetic properties, and then basically we see properties in these external hypercubes manifesting themselves within our inner one, and we see things like electricity and magnetism in our reality that way. So these are the shared dimensions. So the idea is pretty simple. If you take a look here, you can see the shared dimensions are, you have the top dimension, the back, right, front, and a left for sake of argument. These names are arbitrary, but the inner one has XYZ, which is our normal local dimension, and then this box here shares XY with our inner one, and it has its own Z left. And this one has z minus z left. So in other words, two of the three dimensions are shared with the inner dimension. So the outer dimension has three dimensions, and two of them are shared with the inner one. Now, if you were to somehow be able to jump into this outer cube here, it would appear just like our normal space if you could do that. But it would have the properties of that location. But we exist in here, right? So we exist in the inside of the tesseract. We're in here. We're in this section here, and these shared dimensions are coming into our reality, and we're experiencing them in two-dimensionally, even though they're three-dimensional properties. Um, so that's kind of a drawing of it. So the idea is pretty simple, that you have, say for example, you have electric and magnetic. So the electric wave is in xy. So this is movement in xyz left and xy minus z left. So in other words, we only see the electric wave in xy, but there is a third dimension to it, which is the tesseract idea. So it's the third dimensional property here. So it's an object in here moving through here, probably to the other side and back again, and we're only sharing two of the dimensions, so we see it like this. Okay, so that's the idea. That's the core idea of electromagnetism in pi space, and I think it's a pretty unique approach. It's pretty much unique to pi space. So that's the idea. So a charged pi shell is in 4 dimensions, and it has each of these outer dimensional boxes have 3 dimensions, and on each plane in our reality, the one we live in, we only experience, we share 2 of the dimensions, and that's why we see things like electromagnetism in this way, and why they're perpendicular to each other. So this is the reason for the geometry of electromagnetism. So the idea of the pi space theory is that electromagnetism is a higher dimensional pi shell manifesting itself in our lower dimension, and because of that we get these various rules people have to learn, like the right hand rule, the left hand rule, and the electromagnetic wave, and so on. And I can talk later in other lectures about drilling down into each of the individual properties, like the electric fields and the magnetic fields. But the key concept is it's a 4-dimensional charges a 4-dimensional pi shell. That's it. Thanks.